Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math B2 Variant 2 May-June 2018. Let's get started. One morning, Marsha works from 8:20 to 11:15. Find how long she works for. Give your answer in hours and minutes. To get how long she works, we subtract 8:20 from 11:15. Under the minute column, we can't subtract 20 from 15. So we get 1 hour from the hour column, which becomes 60 minutes under the minute column. So we now have 75 minutes. 75 minus 20 is 55. Under the hour column, 10 minus 8 is 2. So we have 2 hours, 55 minutes. Expand. 7 times x minus 8. To expand the brackets, 7 multiplies each of the elements in the bracket. So 7 times x is 7x and 7 times negative 8 is negative 56. Here is a sequence. Find the value of A and the value of B. When we look at the sequence, we see that the difference between the terms keeps decreasing by -2. This means A minus 2 should be equal to 13, so we get A to be 15. Then we also see that -15 minus 12 should be equal to B, so B is -27. Complete these statements. When W equals blank, 10W equals 70. If 10W equals 70, then we need to divide both sides by 10 to get the value of W. This gives us W equals 7. When 5x equals 15, 12x equals blank. If 5x equals 15, then we need to divide both sides by 5 to get the value of x. This gives us x equals 3. Now that we have the value of x, then 12x is 12 times 3, which is equal to 36. Work out the difference between the two prime numbers in the list above. The two prime numbers in the list are 17 and 41. So 41 minus 17 is 24. Without using your calculator, work out 2 over 3 minus 1 over 12. You must show all your working and give your answer as a fraction in its simplest form. First, we need to find the LCM of 3 and 12, which is 12. For 2 over 3, since we multiply 3 by 4 to get 12, then we also need to multiply 2 by 4, which is equal to 8. For 1 over 12, since we multiply 12 by 1 to get 12, then we also need to multiply 1 by 1, which is equal to 1. 8 minus 1 is 7. This cannot be simplified further, so our final answer is 7 over 12. A and B are two towns on a map. The bearing of A from B is 140 degrees. Work out the bearing of B from A. In the illustration, we've indicated the bearing of A from B, which has been given as 140 degrees. We've also indicated the bearing of B from A. Before we can get this bearing, we need to find this angle. Since these two angles are interior angles, then we get the angle by subtracting 140 degrees from 180 degrees, which is equal to 40 degrees. So now the bearing of B from A is 360 degrees minus 40 degrees, which is equal to 320 degrees. Here are some numbers written in standard form. From these numbers, write down the largest number. Looking at the list, the largest number will definitely come from the numbers with a positive power. The number with the highest positive power is the largest number, and that is 1.36 times 10 raised to the power 6. From these numbers, write down the smallest number. From the list, the smallest number will definitely come from the numbers with a negative power. The smallest power value is -3, and so the smallest number is 5.21 times 10 raised to the power -3. Using a straight edge and compasses only, construct the locus of points that are equidistant from A and B. In other words, we are to construct the perpendicular bisector of AB. So first, using a set of compasses and a pencil, we stand at point A, then open the compass to a width that is more than half the length of AB, and inscribe a set of arcs above and below the line. Without changing the compass width, we stand at point B and inscribe another set of arcs above and below the line. From here, all we need to do is to draw a straight line passing through the intersection points of the two sets of arcs. Factorize completely. Xy plus 2y plus 3x plus 6. The first two terms have a common factor of y. When we factor that out, we are left with x plus 2. The final two terms have a common factor of 3. When we factor 3 out, we are left with x plus 2. This expression can be rewritten as x plus 2 times y plus 3. The diagram shows two mathematically similar triangles, T and U. Two corresponding side lengths are 3 cm and 12 cm. The area of triangle T is 5 cm squared. Find the area of triangle U. For similar shapes, we know that the ratio of their areas must be equal to the square of the ratio of their corresponding sides. When we make the area of triangle U the subject, this is what we have. When we type this into the calculator, we have 80 centimeters squared. Anna walks 31 kilometers at a speed of 5 kilometers per hour. Both values are correct to the nearest whole number. Work out the upper bound of the time taken for Anna's walk. Since we are correcting the distance and speed to the nearest whole number, we bring in plus and minus 1, then we divide 1 by 2. We can find the time for Anna's walk by dividing the distance she traveled by her speed. We are interested in finding the upper bound of t, so that would be equal to the upper bound of d divided by the lower bound of v. The upper bound of d is 31 plus 1 over 2 kilometers, and the lower bound of v is 5 minus 1 over 2 kilometers per hour. When we type this into the calculator, we get 7 hours. The histogram shows information about the time, t minutes, spent in a shop by each of 80 people. Complete the frequency table. To get the frequency or the number of people for the intervals, we multiply the frequency density by the interval width. So for the interval t is greater than 5 and less than and equal to 15, the interval width is 15 minus 5, which is 10, and the frequency density is 1.5. So 1.5 times 10 gives us 15. For the interval t is greater than 30 and less than and equal to 50, the interval width is 50 minus 30, which is 20, and the frequency density is 1.1. So 1.1 times 20 gives us 22. The diagram shows a solid cuboid with base area 7 centimeters squared. The volume of this cuboid is 21 centimeters cubed. Work out the total surface area. Here is the formula for the surface area of a cuboid. We've been given the length L as 7 centimeters and the width W as 1 centimeter. We've not been given the height h of the cuboid. We've been given the volume V of the cuboid, so we can find h using this formula. When we make h the subject, this is what we have. When we plug in the values of V, L, and W into the equation, this is what we have, which is equal to 3 centimeters. Now we can plug in the values of L, W, and H into the surface area formula. When we type this into the calculator, we get 62 centimeters squared. Find the volume of a cylinder of radius 5 centimeters and height 8 centimeters. Give the units of your answer. Here is the formula for the radius of a cylinder. The radius r has been given as 5 centimeters and the height h has been given as 8 centimeters. When we type this into the calculator, we get 628 centimeters cubed, rounded to 3 significant figures. The diagram shows a circle center O. AB is a chord of length 12 centimeters. M is the midpoint of AB and OM is 4.5 centimeters. Calculate the radius of the circle. To get the radius r of the circle, we apply the Pythagoras theorem to the right-angled triangle OBM. This gives us r squared equals OM squared plus BM squared. When we make r the subject and plug in the values of OM and BM, this is what we have. When we type this into the calculator, we get 7.5 centimeters. The diagram shows information about the first 8 seconds of a car journey. The car travels with constant acceleration, reaching a speed of v meters per second after 6 seconds. The car then travels at a constant speed of v meters per second for a further 2 seconds. The car travels a total distance of 150 meters. Work out the value of v. We know that the area under a speed-time graph gives us the distance traveled. In this case, the area under the graph is in the shape of a trapezium, and here is the formula for the area of a trapezium. We've been given the distance traveled as 150 meters. A plus B represents the sum of the parallel sides of the trapezium, which is 2 plus 8. The height h of the trapezium is v, which is what we are finding. Half of 2 plus 8 is 5. When we divide both sides by 5, we get v equals 30. A ball falls d meters in t seconds. D is directly proportional to the square of t. The ball falls 44.1 meters in 3 seconds. Find the formula for d in terms of t. In mathematical terms, we write d is directly proportional to t squared. We can rewrite this as d is equal to a constant, which we are going to call k, times t squared. We need to find the value of k. We get k by plugging in the values of d and t given in the question. So we have 44.1 equals k times 3 squared. 3 squared is 9. When we divide both sides by 9, we get k equals 4.9. Now that we have the value of k, then d equals 4.9 t squared. Calculate the distance the ball falls in 2 seconds. In this case, t is 2, so d equals 4.9 times 2 squared meters, which is equal to 19.6 meters. Find the two inequalities that define the region on the grid that is not shaded. First, we need to find the equations of the lines or the boundaries. We get the equation of this line as y equals 3 minus x. The region that is not shaded is above the line, so we have y is greater than and equal to 3 minus x. We attach an equal sign to the greater than symbol because y equals 3 minus x has been drawn with a solid line. The equation of this line is y equals 2. The region that is not shaded is above this line, so we have y is greater than 2. We do not attach an equal sign to the greater than symbol because y equals 2 has been drawn with a broken line. Here are four matrix calculations: AI, IA, C squared, and B plus I. Work out which matrix calculation does not give the answer 1919. When we carry out the matrix operations, the only matrix calculation that does not give us 1919 is C squared. Find the determinant of matrix B. To get the determinant of matrix B, we subtract the product of the minor diagonal, which is 1 times 9, from the product of the major diagonal, which is 0 times 8. This gives us -9. Explain why matrix A has no inverse. This is because the determinant of matrix A is 0. The scatter diagram shows the value in thousands of dollars of 8 houses in 1996 and the value of the same houses in 2016. One of these 8 houses had a value of $70,000 in 1996. Write down the value of this house in 2016. On the grid, when we map $70,000 from the horizontal axis, we get $140,000. The values of 2 more houses are shown in the table. On the scatter diagram, plot these values. On the grid, we plot the point whose value in 1996 was $40,000 and in 2016 was $80,000. Then we plot the point whose value in 1996 was $80,000 and in 2016 was $150,000. On the scatter diagram, draw a line of best fit. On the grid, we've drawn a line of best fit for the scatter plot. The general rule of thumb for drawing a line of best fit is to ensure that the line passes through as many points as possible while balancing an equal number of points above and below the line. Another house had a value of $50,000 in 1996. Find an estimate of the value of this house in 2016. On the grid, we map $50,000 from the horizontal axis onto the line of best fit. This gives us $96,000. In the diagram, O is the origin, OC is -2a plus 3b, and OD is 4a plus b. Find CD in terms of A and B in its simplest form. CD can be expressed as CO plus OD. CO is -OC and that is 2a minus 3b, and OD is 4a plus b. 2a plus 4a is 6a and -3b plus b is -2b. So we have 6a minus 2b. DE is a minus 2b. Find the position vector of E in terms of A and B in its simplest form. The position vector of E is the same as vector OE. OE can be expressed as OD plus DE. OD is 4a plus b and DE is a minus 2b. 4a plus a is 5a and b minus 2b is -b. So we have 5a minus b. The Venn diagram shows information about the number of elements in sets A, B, and the universal set E. The number of elements in A union B is 23. Find the value of x. Since the number of elements in A union B is 23, then we have 20 minus x plus 8 minus x equals 23. 20 plus 8 is 28. Minus x plus x minus x simplifies to minus x. When we make x the subject, this is what we have. 28 minus 23 is 5. An element is chosen at random from the universal set E. Find the probability that this element is in A union B complement. This probability is equal to the number of elements in A union B complement, which is 7, divided by the total number of elements, which is 30. Box A and Box B each contain blue and green pens only. Raphael picks a pen at random from Box A and Paulo picks a pen at random from Box B. The probability that Raphael picks a blue pen is 2/3. The probability that both Raphael and Paulo pick a blue pen is 8/15. Find the probability that Paulo picks a blue pen. The probability that both Raphael and Paulo pick a blue pen is equal to the probability that Raphael picks a blue pen from Box A and the probability that Paulo picks a blue pen from Box B. The probability that Raphael and Paulo both pick a blue pen is 8/15. We know the probability that Raphael picks a blue pen from Box A is 2/3. The end becomes times. When we divide both sides by 2/3, we get the probability that Paulo picks a blue pen from Box B to be 4/5. Find the probability that both Raphael and Paulo pick a green pen. The probability that both Raphael and Paulo pick a green pen is equal to the probability that Raphael picks a green pen from Box A and the probability that Paulo picks a green pen from Box B. To get the probability that Raphael picks a green pen from Box A, we simply subtract 2/3 from 1. To get the probability that Paulo picks a green pen from Box B, we simply subtract 4/5 from 1. The end becomes times. When we type this into the calculator, we get 1/15. P is the point 16.9 and Q is the point 22.24. Find the equation of the line perpendicular to PQ that passes through the point 5,1. Give your answer in the form y equals mx plus c. All we need to do is find the values of m and c of the line and plug in these values into the equation y equals mx plus c. By applying the gradient formula, we get the gradient of PQ to be 24 minus 9 over 22 minus 16, which is equal to 5/2. Since the line is perpendicular to PQ, the product of their gradients must be equal to -1. So we get the gradient of the line to be -2/5. To get the value of c, we plug in the values of m and the coordinates 5,1 into the equation. This gives us c equals 3. So we have y equals -2/5x plus 3. N is the point on PQ such that Pn equals 2nq. Find the coordinates of n. To get the x-coordinate of n, we add 2/3 of 22 minus 16 to the x-coordinate of p, which is 16. This gives us 20. To get the y-coordinate of n, we add 2/3 of 24 minus 9 to the y-coordinate of p, which is 9. This gives us 19. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.